learned brother engineers and other well-wishers. Namaste. As you all very much know, we the Panchayat Raj engineers are executing works under various grants spread over nook and corner places. We are working under various restraints, say through contractors, through village committees, through aikatdars, through school committees who are absolutely having no technical knowledge, unlike professional contractors. Besides that, we the Panchayat Raj engineers are executing works quite improportionate to the men available in the department. Of course, not in sense of money, but with sense of number of works and area over which the works are spread over. Hence, there is more responsibility on Panchayat Raj engineers to have enough knowledge over quality control aspects and also to cultivate such quality control aspects to these executive agencies who are absolutely non-technical. Hence, number of refresher courses are required for this purpose and this project taken up under the cooperation and inspiration of the Panchayat Raj engineers of Guntur district. This video presentation includes quality control procedures, test procedures and certain illustrations of common failures. Dear sirs, we will be very much grateful and welcome your valuable suggestions and advices to duly correcting if any errors that have been noticed in this section and also advices to strengthen the program further. We are very much thankful to the Panchayat Raj engineers of Guntur district for their cooperation extended in formulating this program. I must also congratulate Mr. Shantaram and Mr. Virabhadrayav and their team of engineers who have put their sincere efforts in making this program. Thank you all, thank you all, thank you all. Please go through the program.
The history of cementing material is as old as the history of engineering construction. The story of invention of Portland cement is however attributed to Joseph Aspelin in 1824. Portland cement was first manufactured in India in 1904 near Madras. Since then, the cement is widely used in construction of various engineering structures. It has proved to be one of the leading engineering materials of modern times and has no rivals in production and applications. The cement is now available in a wide range of varieties depending upon the chemical composition and properties. Selection of cement to suit the type of work taken up and the other conditions of execution is an important task of civil engineer. There are certain tests which can be conducted on the cement to use them as a guide for the selection of suitable cement. Tests on cements may be brought under two categories. Number one, field testing. Number two, laboratory testing. Minor works, field tests are sufficient to draw inferences about its suitability. For major type of construction, the laboratory tests are conducted, which includes number one, test of normal consistency. Number two, test of fineness. Number three, initial setting time and final setting time. Number four, strength test. Number five, soundness test. Now let us see how the field tests are conducted in the field.
Open the bag and take a good look at the cement. There should not be any visible lumps. The color of cement should normally be greenish grey. Thrust the hand into the cement bag. It must give you a cool feeling. Take a pinch of cement and feel between the fingers. It should give a smooth and not a gritty feeling. Take a handful of cement and throw it on a bucket full of water. The particles should float for some time before they sink. Make a stiff paste of cement and Put a cake with sharp edges. Put it on a glass plate and slowly take it under water. See that the shape of cake is not disturbed while taking it down. After 24 hours, the cake should attain some strength without change in its shape.
Now let us see fineness of cement test. Fineness of cement has an important bearing on the rate of hydration and hence on the rate of gain of strength. Finer particles offers greater surface area of hydration and hence the faster and the greater the development of strength. A good cement should have an average particle size of 10 microns and maximum number of particles should have less than 100 microns. The size of fraction below 3 microns will have dominant effect on the one-day strength. The fraction between 3 to 25 microns will have effect on 28-day strength. This fineness test is conducted to know the fraction of fineness retained as 90 microns, whose presence is limited to 10% based on the strength criteria. Disadvantage of more fineness of cement. Number 1, susceptibility for age setting. Number 2, early deterioration. Number 3, more drying shrinkage of concrete. Testing methods now by sieving, by air permeability. Let us now see how this test will be conducted.
Take 100 grams of cement into 90 microns IS sieve. Break down air set lumps if present with the fingers. Sieve the sample for about 15 minutes. Weigh the residue left in the 90 micron sieve. Now the weight of the residue left in the 90 micron sieve is expressed as the percentage of original weight of the cement taken. Recommendations of fineness of cement as per IS 269/1976. The residue left in the 90 micron sieve should be less than 10% for ordinary Portland cement. This should be less than 5% for rapid hardening cement. The setup now looking is for determination of normal consistency. Normal consistency of cement may be defined as that percentage of water which allows the plunger to penetrate to a depth of 5 to 7 mm from bottom is known as the normal consistency. This test is prerequisite as the quantity of water to be used for different tests is based on this normal consistency value only. Now let us see the operators required for this normal consistency. Number 1, Wicott's apparatus, which is as per the IS 5513/1968, whose penetration values are graduated from bottom to the top, that is 0 to 50. Number 2, plunger of 10 mm dia and 50 mm long. Mold of 80 mm dia and 40 mm deep. Non-porous plate to place the mold and sample. Now let us see the procedure. Take 500 grams of cement. Now, as a first trial, prepare a paste by adding 25% of water by weight of cement. Fill the mold placed on a non-porous plate with the cement paste within 3 to 5 minutes from the time of addition of water to the cement. Shake the mold to expel the water. Now place this Vicot's mold on the Vicot's apparatus. Now plunger of Vicot's apparatus is brought down to touch the sample and allowed to fall quickly into the cement paste. Take the reading now by depth of penetration. Now see the reading which is more than the reading required for normal consistency, which indicates that the percentage of water added to the cement is less than required for the normal consistency. Now as a second trial, let us add some more water to the cement and test it for the normal consistency until the plunger of Vicot's apparatus penetrates to a depth when measured from bottom of the mold reads 5 to 7 mm, as you can see in the reading now. Result: report the percentage of water required for above process as percentage of water required to produce the normal consistency P.
Now, regarding initial setting time. Initial setting time may be defined as the time elapsed between the moment that the water is added to the cement to the time that the paste starts losing its plasticity. In actual practice, starting point of losing plasticity and end point totally losing plasticity and time scale are very much important while dealing with the cement paste or concrete. Since certain time is required for mixing, transporting and placing the concrete should remain totally in plastic condition during mixing and handling operations. Normally, a minimum period of 30 minutes is required or recommended for these operations to be carried out before concrete starts losing its plasticity. Initial setting time is to be found to know the time available for mixing and handling operations for a given cement and also to schedule the above operations according to the availability of the time. Now, regarding final setting time. Final setting time may be defined as the time elapsed between the moment that the water is added to the cement to the time that the cement paste has completely lost its plasticity. No operations are to be done beyond this time. Let us go to the testing procedures now.
Now let us see the apparatus required for the initial setting time. Number 1. Vicot's needle apparatus as per the IS 5513-1969 with a needle of 1 mm square. Number 2. Mold. Number 3. Stopwatch. Number 4. Non-porous plate. Number 5. A balance. Preparation of test black. Take 400 grams of cement into a porcelain dish. Add 0.85 times the quantity of water required for normal consistency. Mix the paste thoroughly and place the paste in the Vicot's mold, which is placed on a non-porous plate. Start the stopwatch at the instant when the water is added to the cement. Level off the surface and place the mold under the Vickot's apparatus needle. Lower the needle gently in contact with the surface of the test block. Quickly release the needle to penetrate into the test block. As you can see, the needle that is completely pierced the test block. That means that the initial setting time of cement is not yet come. Repeat the process of releasing the needle at regular intervals until the needle fails to pierce the block for 5 plus or minus 0.5 mm measured from bottom of the mold. As you can see now in the reading, it is about 5.5 mm from the bottom of the mold, which indicates it has now reached the initial setting time period. Result. Report the time elapsed between the moment that the water is added to the cement to the time when the needle fails to pierce the test block, as seen above as the initial setting time of cement. That is the time available for mixing and handling operations to be carried out in the field. Recommendations. The initial setting time of cement should not be less than 30 minutes for ordinary Portland cement. Now for the final setting time, replace the needle of Vickot's apparatus with a needle with annular ring. The needle is gently applied on the surface of test block. Now you see not only the needle but also the outer ring has made an impression on the sample. This means that final setting time of cement has not yet reached. This process of application of needle is repeated until the needle makes an impression on the test block but the outer ring fails to do so. Now as you can see, the inner needle of the Vickot's apparatus made an impression but the outer ring has failed. This indicates the time of final setting time of the cement. Report this period elapsed between the time when the water is added to the cement and the time which the needle makes impression and the outer ring fails to do so as a final setting time. Recommendations. The final setting time should not be more than 10 hours for ordinary Portland cement.
Now, soundness by Lee Chatelier method. Certain cements have been found to undergo a large expansion after setting, which causes the disruption of the set and hardened mass. This will cause serious difficulty for the durability of the structures when such cements are used. This unsoundness is due to the presence of excess of lime then that could be combined with acidic oxide at the kiln. It is also due to insufficiency in fineness of grinding, too high proportion of magnesium content, etc.
Now, let us see the apparatus required for the soundness test of the cement. This method is by the Lee Chartlier's apparatus. This apparatus consists of a small split cylinder of spring brass of 0.5 mm thick, 30 mm internal dia and 30 mm height. On either side of split mold, two indicators are attached with pointed ends. Length of these indicators is 165 mm. Non-porous or glass plates to cover the apparatus on top and bottom. Mixing dish, small trowel, stove and dish for heating to boiling temperature. Now let us see the procedure. Take 200 grams of cement into the mixing dish. Add 0.78 times the water required for the normal consistency. Mix it thoroughly to get uniform paste. Put it in the split cylinder which is placed on glass plate. By taking care to keep the indicators together during this operation. Cover the cylinder with the glass plate and place a small weight on the glass plate. Put the entire setup in the water for 24 hours. Take out this cylinder and measure the distance between two indicators. Let it be L1. Place the cylinder again in the water and the temperature rise to boiling temperature in about 35 minutes and allow it to boil for 3 hours. Take out the sample now and allow it to cool to the room temperature and measure the distance between the two indicators of the split cylinder at the point ends. Let this distance be L2. The difference between the values L1 and L2 is called the soundness of cement. An average of 3 such samples will be reported as the soundness value of the cement. Recommendations. Soundness value of a given cement should not be more than 10 mm for a good ordinary Portland cement as per IS specifications.
Now, regarding strength of cement. The compressive strength of hardened cement is the most important of all the properties. Therefore, the cement is always tested for its strength in the laboratory before the cement is used in the important works. The strength of cement is found on the cement mortar of 1:3 ratio using sand conforming to the IS 650-1960 supplied by the Tamil Nadu Mineral Development Corporation.
Now let us see the apparatus and material required for the strength test of cement. This is sand conforming to the IS 650 1960. This sand is available in three different grades: grade 1, grade 2, grade 3. For our testing purpose, these three grades are to be mixed in equal proportions. Next, the vibrating machine, measuring jar, mixing dish, vise, balance, stopwatch, mold of 7.06 centimeter size as per IS 4031 1968. Now let us see the procedure of this strength test. A thin film of petroleum jelly is applied to the contact surfaces of bottom of mold and its base to avoid water escapes during vibration. After applying the petroleum jelly, fix the mold in the vise and place the assembled mold on the table of vibration along with vise. Finally, hold it in position by means of suitable clamps on the vibration machine. Now, place the sample of cement 200 grams into the mixing dish. Take 600 grams of sand, duly mixing sands of grade 1, grade 2, grade 3 in equal proportions. Total of 600 grams of sand is taken. That is the proportion of 1:3 by weight. Add water to the mix. Quantity of water to be added will be P by 4 plus 3% of combined weight of cement and sand, where P is percentage of water required for normal consistency. Mix it thoroughly to get uniform paste. This process of adding water and mixing to get the uniform paste should be completed within 4 minutes from the addition of water to the cement, and this should be conducted at 27 degree centigrade temperature. Place the sample in the mold fixed on the vibration machine now. The mortar will be tamped with a rod for 20 times. Mix is placed again in the mold and tamp it again for 20 times. Vibrate the vibration machine for 3 minutes. Remove the mold with the base plate and smoothen the surface with a trowel. Keep it in the room temperature for 24 hours. Then remove it from the mold. Keep it in water curing for 27 days. Three such molds are prepared. One is for 3 days testing. Second is for 7 days testing. And the third one is for 20 days testing. Test the specimen in the compressor testing machine by placing the cube in between the platens of the testing machine and apply the load at an uniform rate. Note down the load taken by the sample at its total failure. Load taken by the cube divided by area of the face of the cube which is in contact with the platens of the compression testing machine will be the compressive strength of the cement. Recommendations of the compressive strength values of the ordinary Portland cement are as follows. For 33 grade cement on 3 days testing, the compressive strength should not be less than 160 kg per centimeter square. For 43 grade cement, it should not be less than 230 kg per centimeter square. For 53 grade cement, it should not be less than 270 kg per centimeter square. On 7 days curing, for 33 grade cement, it should not be less than 220 kg per centimeter square. For 43 grade cement, it should not be less than 330 kg per centimeter square. For 53 grade cement, it should not be less than 370 kg per centimeter square. On 28 days curing, it should not be less than 330 kg per centimeter square for 33 grade cement, 430 kg per centimeter square for 43 grade cement, and it should not be less than 530 kg per centimeter square for 53 grade cement as per the IS specifications as you see in the table now.
Aggregate. Aggregate is the prime engineering material both in the concrete and pavement construction. As a material for concrete, it is important constant as it occupies 70 to 80% of total volume of concrete. And hence, to know more about concrete, it is essential to know more about aggregate. And as a material for pavement construction, aggregate occupies major part of the pavement layers such as base courses like waterbound macadam, wearing courses like concrete and blacktop surface dressing layers, etc. Hence, the study of coarse aggregate for their suitability with respect to their strength, durability, shape, size, specific gravity and bulk density, etc. is a must before it is going to be used for specific purposes like material for concrete or material for construction. Besides the strength aspect, the aggregates are classified as coarse aggregate and fine aggregate depending upon their size. The material ranging from 80 to 4.75 mm is called coarse aggregate and the aggregate material finer than 4.7 mm is called fine aggregate. The tests conducted on coarse aggregate and fine aggregate are different. Now let us see the tests that are to be conducted on coarse aggregate, and they are namely 1. Grading of aggregates, bulk density of aggregates, shape tests like elongation index and flakiness index, and crushing value test, impact value test, and Los Angeles appression value tests. Aggregate grading or sieve analysis. Grading of aggregate is one of the most important factors for producing workable concrete. Good gradation of aggregate means sample of aggregate which contains all fractions of the aggregate and must have minimum voids. Good grading of aggregate makes the less quantity of cement to be used in concrete, thereby making concrete economical, higher strength, lower shrinkage, and greater durability. A good grading with respect to pavement construction is the grading which makes the aggregate to pack closely and develop good interlocking within the layers during the compaction process. Grading of aggregate is done by sieve analysis. Now, let us see this grading of aggregates.
The sizes of the sieves specified as per IS for grading of aggregates are: for core sieves 80 mm, 63 mm, 50 mm, 40 mm, 31.5 mm, 20 mm, 16 mm, 12.5 mm, 10 mm, 6.3 mm, 4.75 mm with square holes perforated plate. For fine sieves, sieve sizes are 3.35 mm, 2.36 mm, 1.18 mm, 600 microns, 300 microns, 150 microns, and 75 microns. Minimum weight of sample to be tested for gradation of aggregate as per IS 2386 Part 1 1963 is as per the table shown in the IS code. For maximum size of aggregate 63 mm size aggregate, minimum weight of sample should be 50 kg. Like that, for a minimum size of aggregate sample, for a aggregate size of 2.36 is given in this table. Material preparation. Material is oven dried at 100 to 110 degrees centigrade for 4 hours before the sieve analysis or gradation is done. Observation sheet. In the observation sheet covers serial number, IS sieve number, weight retained, percentage of weight retained, cumulative percentage of weight retained, percentage of passing. After sieving is done through the series of sieves, the results are tabulated in the table shown. Now let us see the grading requirements for the different usage of aggregates. Grading requirements of coarse aggregates for concrete works. Table 2 of IS 383/1970 specifies that the aggregate conforms to this table should be only used for the concrete purposes. Left hand side portion of this table specifies the single sized aggregates to be used in the concrete. For the 63 mm single sized aggregates, 40 mm single sized aggregates, 20 mm single sized aggregates, 16 mm single sized aggregates, 12.5 mm single sized aggregates, 10 mm single sized aggregates are covered in the left hand portion of the single sized aggregates. And the right hand portion of the table comprises of the graded aggregate details, which comprises of 40 mm graded aggregate, 20 mm graded aggregate, 16 mm graded aggregate, and 12.5 mm graded aggregate, which can be obtained by mixing the single sized aggregates shown in the left hand side in different proportions. Now let us see the single sized aggregates and graded aggregates of 40 mm, 20 mm and 12.5 mm. This is a sample of single sized aggregate of 40 mm size. This is a sample of 20 mm size single sized aggregates. This is a sample of 12.5 mm single-sized aggregate. Now let us see the graded aggregates of respective sizes. This is a sample of 40 mm graded aggregate. This is a sample of 20 mm size graded aggregate. This is a sample of 12.5 mm graded aggregate. Now you can have the idea of difference between single sized aggregate and the graded aggregates of 40 mm, 20 mm and 12.5 mm sizes, which are widely used for the concrete purposes. Now let us see the sizes of coarse aggregate for mass concrete. This is as per table 3 of IS 383/1970. This table specifies the different sizes of aggregates to be used for the mass concreting purposes, varying the sizes from 150 mm to the 4.75 mm size. For huge mass concreting purposes, these sizes are to be used. All-in aggregate grading. This is as per the table 5 of IS 383/1970. This comprises of both coarse aggregate and fine aggregate. As you can see, the size of the aggregates are mentioned here, right from 80 mm to the 150 micron. This means it comprises of both fine aggregate and coarse aggregate. This table shows the grading requirements of the fine aggregates to be used in the concreting purposes. This is as per the table 4 of IS 383/1970. The gradings have been divided into 4 zones. Zone 1, Zone 2, Zone 3, Zone 4. As you go from Zone 1 to Zone 4, the aggregate size becomes finer. Zone 4 is restricted to use in the RCC purposes. Now let us have a look at the fine aggregates of Zone 1, Zone 2, Zone 3, Zone 4. This is sand of Zone 1 grading. This is a coarser one with a fineness modulus of nearly 3.5. This is Zone 2 graded fine aggregate. This is most ideal to use in the concreting purposes. Its fineness modulus ranges from 2.8 to 3.2. This is Zone 3 grading of fine aggregate. This is still finer than the Zone 2 aggregate, whose fineness modulus ranges from 2.5 above. This is Zone 4 aggregate, still fine aggregate. Its usage is restricted for the RCC purposes. Now let us see the grading requirements of coarse aggregate for road works. You have 2 tables here. Top table shows the single-sized aggregate specification as per the table 500-25 of most specification, and the bottom table shows is as per the table 1501A of APSS. The single-sized aggregate to be used in the road purpose should conform to any one of these 2 tables. This table shows the grading requirements of coarse aggregates for the roadworks. This is as per the table 400-7 of most. There are 3 gradings given in the table. Grade 1 ranges from 90 mm to the 45 mm size. Grade 2 ranges from 63 mm to the 45 mm. And grade 3 ranges from 53 mm to the 24 mm size aggregates. Different gradings can be obtained by mixing the different proportions and sizes of the aggregates from the tables shown before in the percentages shown in the 4th column of the table. Now let us see the aggregate sample or aggregate grading requirement for the open graded premix carpet. This is as per most class 509. Quantity of aggregate to be used is 0.27 cubic meter per 10 square meters. The other requirements are as shown in the table. The material looks like this. Now let us see the grading requirements of aggregate sample for BTST or BTRC as per APSS clause number 1510. Quantity of aggregates used for this purpose is 0.27 cubic meter per 10 square meters, and other requirements are as per the table shown. The material meeting the requirements is as shown here. Now let us see the aggregate grading requirement for the BT seal coat as per APSS clause number 1512. Binder material used for this purpose is 9.8 kg per 10 meter square. The aggregate material meeting the requirement looks like this.
Determination of bulk density of aggregate. Bulk density of aggregate is important property to be known before it is going to be used in the pavement construction. Since the qualitative and quantitative assessment, even after completion of the road pavement, is done with the help of the bulk density value of the aggregate only. Hence, it is recommended to conduct the test of bulk density before taking up the road and recording it on the right side of the measurement book for the future reference of quantity and quality assessment. Now let us see how this test is conducted.
Now let us see the apparatus required for the determination of bulk density of the aggregate. Cylindrical metal measures of 3 liter, 15 liter or 30 liter capacity chosen depending upon the size of the aggregate to be tested. Tamping rod of 16 mm diameter and 60 cm long, rounded at one end. A balance of 0.5% of weight of sample to be weighed. Now let us see the procedure how this bulk density of aggregate is determined. Select the capacity of the cylindrical metal measure to be used depending upon the size of the aggregate, basing on the IS shown in the table for determination of bulk density of aggregates. As you can see in the table, the sample now selected passes through the 40 mm sieve and retained on 4.75 mm sieve. The corresponding metal measure for determination of bulk density is 15 liter capacity, whose inside diameter is 25 cm and whose inside height is 30 cm. Thickness of wall of measure is 4 mm. Now this metal measure is selected. Now the measure shall be filled with the metal in about 3 different layers, each being tamped with tamping rod for 25 times. Here this tamping is for best possible naturalization of orientation of aggregate particles, not for compaction. After filling, level the surface of the filled measure neatly to flush with the sides of the measure. Now weigh the sample of the aggregate filled in the measure and report the bulk density of aggregate as weight of sample of aggregates in the measure divided by its volume. Recommendations. The value of bulk density of aggregate thus found may be recorded on the right hand side of the M-book for future reference during the quality control inspections and inspection by the other higher officers.
Elongation index of aggregates. Elongation index may be defined as the percentage by weight of the aggregate whose greatest dimension or length more than 1.8 times of mean dimension of the aggregate. Inferences. Too elongated material is not workable. They are likely to break under smaller loads than the aggregates which are spherical or cubical, hence not recommended for bearing coats. Now let us see how this test is conducted.
Now first let us see the apparatus required for the elongation index of aggregate. First, length gauge. This is as per 2336 part 1 1977. balance. Thirdly, IS sieves of 63 mm, 50 mm, 40 mm, 31.5 mm, 25, 20, 16, 12.5, 10 and 6.3 mm sizes. Now let us see the procedure of determination of elongation index of the aggregates. Take a fraction of aggregate sample, passes through the 20 mm sieve and retained on 16 mm sieve is taken. 200 pieces of the aggregate is selected from the sample of the aggregate taken. The slot on the length gauge corresponding to this fraction of aggregate is selected. Now the material is tested piece by piece whether the entire fraction of aggregate processed through the slot or not. The material is now collected in two heaps. One heap contains the material which passes lengthwise through the slot selected. Another heap contains the material which does not pass through the slot. Weight of each part is weighed separately. This process is completed for other fractions of aggregate by choosing corresponding slot from the length gauge. The sum of weight of all fractions in which pieces pass through the corresponding slots and the total weight of all fractions is to be calculated. The elongation index may be reported as weight of not passing lengthwise divided by total weight of the sample into 100.
Flakiness index of aggregate. Flakiness index may be defined as the percentage of weight of the aggregate whose least dimension or thickness is less than 0.6 mean dimension of the aggregate. Inferences. Too flaky material is not workable. They are likely to break under smaller loads than the aggregates which are spherical or cubical, hence not recommended for bearing code.
Now let us see the operators required for the flakiness index of the aggregate. Number 1, thickness gauge. This is as per IS 2336 part 1 of 1977. Balance and the IS sieves same as that of the elongation index. Now let us see the procedure of determination of flakiness index of aggregates. A fraction of aggregate sample passes through the 20 mm sieve and retained on 16 mm sieve is taken. 200 pieces of such aggregate is selected from the sample